Welcome, and today we are going to learn about correlation functions. So what exactly is a correlation? The degree of similarity between the two finite line sequences is termed as correlation in general. We have classification of correlations, that is the types of correlation as below here. Two types are there. First one is autocorrelation and second is cross correlation. What is autocorrelation here? The degree of similarity between the original and its time shifted sequences is named as the or termed as the autocorrelation. But the cross correlation finds the degree of similarity between totally two different sequences. Now for random processes, we are going to work with both auto and cross correlation functions. The first subtopic is autocorrelation functions. The autocorrelation function of a random process x is given by Rx of tau is equal to expectation of product of x of t with x of t plus tau. That is, expectation of the first term x of t is the original sequence and x of t plus tau is the time shifted sequence here. When we are trying to find the product of these two, then expected value of this, then resultant value is assigned to the autocorrelation function here, where t and tau both are arbitrary in nature. Now we'll go for assumption here. First one, we'll assume tau is equal to 0. So what exactly is tau? So tau is the time difference as we have learned in the previous video here. So for time difference, tau is equal to 0. Equation 1 represents the autocorrelation function which is evaluated at time instant, that is the difference 0 here. So therefore, and it represents the average of random process which is squared. So equation number 1, you can substitute tau is equal to 0. This becomes equal to e into x of t into x of t here. So tau is 0. So therefore this term within the square bracket will become equal to x square of t. So therefore this is the average of the random process which is squared is nothing but equal to average is expectation operator, square of the random process is equal to nothing but the autocorrelation function defined it there with the time difference is equal to 0. Rx of 0 is equal to e of x square of t here. So in general, the above equation can also be called or known as average power of the random process x of t. This is how we go for calculation of the average power of the random process here. So therefore, the autocorrelation function of a random process x of t Rx at with the time difference 0 is equal to square of the, that is random process, and its average is equal to the variance sigma x square plus the mean value, the square of the mean value bu x square here as per equation number 2. So this equation 2 is very important for us to solve any practical problems here. Now the relationship between the variance sigma x square and the average power to the average power AC power and the second term square of the mean to the average DC power is as below here. It's very important. So consider Rx of tau is equal to expectation of product of E of x of tau to x of t plus tau as before. Now in place of the tau, we just go for substituting the negative value of this. So substitute minus tau in place of the tau. So therefore we obtain Rx of tau is replaced by minus tau here. This is equal to E of x of t. Then here t plus tau is there. We replace by t minus tau. Now we also know the important concept that the absolute time does not affect the autocorrelation function. So therefore we can define a new variable here, that is t dash is equal to t minus tau in the above expression. Let us go for introduction. So wherever t minus tau is there here on the right hand side, we just go for replacing this by t dash. So therefore we can also find another relation here that t is equal to t dash plus some time difference tau is there. So equation 3, which is here, this equation 3 can be rewritten after substitution of these two here. That is Rx of minus tau is equal to E of x of t is there. We substitute t dash plus tau. Then x of t plus tau is there. That can be substituted by x of t dash. So therefore, Rx of minus tau is equal to expectation of E x of t dash plus tau. So therefore, we can see that the autocorrelation function is even function of the tau or the time difference as per equation number 4. Let us approach some problems here. So one of the problems we'll just take it for a random process and we'll see how to compute the mean autocorrelation function of any given random process here. So in this example, they have taken a random process is described by represented in figure by y of t is equal to a into cos omega c t plus theta. So here a and omega c are constants, but theta is a random variable which is distributed uniformly between plus or minus pi. Totally around 360 degree, we are having the uniform distribution of the random variable theta here. Now there is a random process in the above equation, that is y is representing the random process and theta is representing the random variable. So therefore the random process in the above equation might be used to represent a carrier signal in AM or FM modulation process in communications. And there is a question here, is y of t, that is a random process y, is it wide sense stationary? If not, then why? If it is wide sense stationary, if so, then what are the mean and autocorrelation functions of the random process? So first we need to find out whether it is wide sense stationary. If not, then why? If yes, then we have to find the mean and the autocorrelation functions for the given random process y. So given data in this, as a part of the solution, you can identify that given data theta is uniformly distributed random variable, whereas y of t is a random process here. Now we know by theory that the PDF for a random variable, uniformly distributed random variable, theta is given by f theta of t is equal to 1 by 2 pi. Since the random variable is defined between the bounds minus pi to plus pi, so therefore this is 1 by 2 pi is there. In all other places where theta is to the left of minus pi or right of plus pi, it's having the 0 value. So therefore this is a PDF of the given random variable, single random variable, that is theta here. Next, the mean of the random process y of t is given by mu y is equal to expectation of y of t. So this is equal to y, this is the sample function which is being indicated as a lowercase y here, multiplied by the, that is the PDF of the random variable which we found in the above, that is mathematical equation here. Then versus the d theta, variation in d theta. The mean value can further be, that is the equations can be substituted and simplified as below here. Now what is the equation for y? So we can go for focusing here on the value now. Now we'll go for solution here. So we were discussing about mean of random process y of t is given by so and so thing, and further we go for substituting the sample function, that is e of y of t, the mean value of the random process y is given by integration between minus to plus pi. Integrate all the area between minus to plus pi, the entire values here. The first one indicated in the red color is a sample function which is given in the question as equal to y of t is equal to so and so thing. So the sample function is substituted as a into cos of omega c t plus theta multiplied by 1 by 2 pi. This 1 by 2 pi is taken from the definition of, that is a PDF. So PDF is equal to 1 by 2 pi between this minus pi to plus pi, elsewhere it's going to be 0. So therefore PDF notation is substituted by 1 by 2 pi and d theta. We take a and 1 by 2 pi which are constants outside the integral limits here. So outside this integration, if we are taking this, then it becomes equal to a by 2 pi minus pi to plus pi cos of omega ct plus theta into d theta. Now we go for integration. This is the form cos a plus b. So let us go for expansion here. By trigonometry we know that cos a plus b can be written as cos a into cos b minus sin a into sin b. But that is enclosed within the parenthesis here, and then written as d theta. Next we go for taking the cos omega c t here in the first term outside the integration, and again we split this into two integral factors here. So first one is having only cos ab, cos a into cos b, so therefore out of which we are going to take cos omega c t outside and integration minus to plus pi. Remaining term is cos theta and d theta here, minus sin omega c t, second term again integration between minus to plus infinity sin theta into d theta. This is written as equal to, then we integrate cos theta here. So integration of cos theta we will be getting, that is sin theta here, sin theta, then apply minus pi to plus pi limits here, minus sin omega c theta t, then integration of sine theta, we get minus cos theta here. So again apply the limits here. Further, upon substitution here, both the upper and the lower bounds are the limits. We get a by 2 pi into cos omega ct, then sine theta, first one is pi, we get the first term, then minus of sine minus pi is there. We know that sine minus theta is equal to plus sine theta. Likewise, sine of minus pi is nothing but equal to minus sine pi. So therefore here minus into minus will become equal to plus, resulting in sine pi plus sine pi. So plus, then sine omega ct is there. So therefore this term minus is taken outside this particular limit and applied here to obtain the plus sign. Next we are having cos theta alone here. So this is cos pi minus cos of, that is minus pi here. So cos of minus pi is again equal to cos pi. So this is, we can see that both in this particular term this is going to cancel out, right? And ultimately we are going to get the that is value of 0 here. A by 2 pi into 0. Whatever is enclosed in the square braces, everything is going to be culminating in a value equal to 0. So therefore this resultant value of 0 is multiplied to obtain the final value. So the mean value of the given random process y is equal to expectation operator of the random process y of t is equal to 0 here. So this means that the ensemble mean or average is always equal to 0. This is a very important conclusion which we can find here. And next we can also focus on the second quantum which is asked here, is statistic is autocorrelation function. So how the signal is or the random process is related to itself with the time shifted version. Now mathematical expression is Ry of tau is equal to E of original random process y of t and time shifted version of the random process y of t plus tau. So therefore again we substitute for y of t and y of t plus tau here, and this equation is expanded as E of a cos omega ct plus theta. This is for the first term y of t, and second term y of t plus tau is there. This is a cos of omega c, then within that braces instead of t it is taken as t plus tau, then plus theta. Hope it is clear now. Therefore now we are having the two products. A into a is nothing but equal to a square. So before we proceed, the first one red color indicates the substitution for y of t. Second blue color which is highlighted is for the second term, that is random process which is time shifted, the y of t plus tau here. We take the a square outside this particular square bracket and the rest of the terms are going to be maintained inside here. So therefore this is nothing but equal to cos omega ct plus theta, cos of omega ct plus omega c tau plus theta here. So be careful here, you are having omega ct then plus omega c tau is there, right? So therefore this is nothing but equal to a square of u of cos of omega ct plus cos of omega ct plus theta, then cos of omega ct plus that is theta is there. So again here the first cos term, cosine term, we are having the cos function, you are having t here one term and tau is one more term here. So therefore the second term is exchanged into the first term's position and vice versa to obtain this particular last equation. Further we take the cos A into cos B form. So by trigonometry we know that product of cos A into cos B is equal to 1 by 2 cos of A plus B plus cos of A minus B. So again we take the A square outside as before, expectation of. So this equation is taken because we can see in the previous equation that this is the form cos A into cos B, right? So therefore this is particularly cos A into cos B form. So therefore we can substitute as per the trigonometric equation which we mentioned as cos A into cos B is equal to so and so term here. Upon substitution we get this cos of 2 omega c t plus omega c tau plus 2 theta plus cos omega c tau. So we can go for further simplification and grouping as per the similarity here. Next we perform the integration. Therefore a square by 2 is taken outside here, again 2 is taken outside, then e of, we are left with expectation operator of the both the terms of cos A plus cos B form. Now we go for integration of these individual terms between the limits, permitted limits, that is minus pi to plus pi. So first term we integrate here, integration of minus pi to plus pi. So expectation operator is nothing but or the mean value is nothing but we are going to find the area which is enclosed within a particular that is limit here. So this is cos 2 omega ct plus omega ct into 2 theta 1 by 2 pi. So you can find the replacement for the that is PDF here, 1 by 2 pi d theta, and again minus pi to cos omega c tau. Again PDF value is 1 by 2 pi between the minus to plus pi, then d theta here. So both the cosine terms we are going to substitute for, that is the PDF along with its function. So next one, this equation will be modified as a square by 2 into 2 pi. You can take 1 by 2 pi common from both the integration symbols, and we get equal to 1 by 2 into 2 pi, that is resulting in a square by 4 pi. The next one, we'll have to look back to the terms here, minus pi to plus pi. The cos of 2 omega c, we can group here t plus tau. Omega c is grouped together to obtain c plus tau here, then plus 2 theta. Next, plus we are having rest of the term here in this particular case. So while you are taking 2 pi outside, we are having a manipulation here. So consider the first term now. First term you can obtain with minus pi to plus pi cos 2 omega c t plus tau plus 2 theta into d theta. This is the integration. You can perform the integration and expand it in the form of cos a cos b minus sin a into sin b as before, and then do the manipulations here. Once you go for doing the manipulations and then substitution after the integration, following the steps here, you will be getting, that is cos 2 theta integration, we are getting sin 2 theta by 2, right? So upon application of the minus pi and plus pi integral, again second one, sin 2 theta is there, its integration will be minus cos 2 theta divided by 2. Again apply this integration. So therefore upon this completion and simplification, we obtain the final value is equal to 0. So therefore this is for the first term. Now for the second term, we can again go for cos omega c tau d theta is only left out here. So we go again for integration of these things and substitute for theta plus and minus of minus pi, resulting in 2 pi here. Then 2 pi cos omega c tau is left. So therefore the autocorrelation function on substitution of first and second terms which we got is nothing but equal to ry of tau is equal to a square by 4 pi. First term resulted in 0, we have substituted, plus second term is 2 pi into cos omega c tau. So we substituted here, and finally we obtained an equation that is for the ACF. ACF is nothing but autocorrelation function denoted by ry of tau in this particular example here. This is equal to a square into cos omega c tau by 2. Therefore, based on the above results, we can also come to some important observations or remarks here. The autocorrelation function which we obtained in this expression, we can very clearly see this, that autocorrelation function or ACF is independent of absolute time t. We don't have the time t presence of time t notation anywhere here, and it depends only on the time difference tau here is indicated. This is expected as per the theoretical concept which we learned. Therefore, y of t, our second question is y of t, the random process, is wide sense stationary? If yes, why? Or if not, then why? You have to give a justification for this. For the present problem, y of t is wide sense stationary. The reason being, you are having y of expectation of y of t, that is the mean value is constant, and autocorrelation function is independent of the absolute time t as noted above here, and it only depends on the time difference tau. Upon satisfaction of both these conditions, we can call any random process is wide sense stationary. So therefore we can come to a conclusion that y of t, or the random process which is taken, is wide sense stationary in nature. Now we can also find the ensemble, that is ensemble variance also. So this is equal to sigma y square is equal to ry of 0. So at tau is equal to 0, we are finding the variance. So therefore this results is equal to a square by 2 here. So this is about the mean, ACF, ensemble variance, etc. This is the end of this particular problem. Likewise, we can have many other problems. In second problem here, random process is described by a into sin omega t. Again, all the other things are same here. So for more problems, you can also visit a blog which is maintained here. It's a very good blog, www.engineeringstatisticsandlinearalgebra.co.in. Further reading here. Thank you.